Hello. So recently one of my videos got picked up by the algorithm. This video is a response to that. It seems like you guys like breasts, so this time we're going to be making another breast theme video. Before we start, I just have a couple of things to mention. So the first is about this channel in general. Believe it or not, this channel is not meant to be an NSFW channel. However, I also don't mind covering NSFW topics. So if there is something that you would like me to cover, please leave a comment. The second thing I want to mention is about staying motivated in Blender. So I think sometimes it's important to do fun things even if they're not very useful just to stay motivated. Certainly when I was starting out in Blender, this helped me out a lot. Like I would just play around with things, not caring too much about the end result, just doing what was fun, setting myself little goals to fulfill. So I think this breast video is basically about that. It's a collection of little challenges that may or may not be useful that are hopefully going to help us learn about Blender. But anyway, with that out of the way, let's get started. These are the topics I'll be covering in this video. So the first one of these is quite simple, but I had to cover it even if only just for myself. And the topic is attaching draperies to the breast. I remember when I was first starting out, this was one of the first things that I tried to do, and I just couldn't do it no matter how hard I tried. But I've come a long way since then, so let me show you how to do it. So I will show you two ways to do this. So the first of the ways is the obvious approach, and that is to give the item that you want to attach to the breast the same transforms as the breast. In this case, there's two things modifying the breasts. There's the surface deform modifier, and there's the armature modifier. So as long as the thing that we want to attach has these two same modifiers on it, and they're weighted correctly, it should follow the breasts perfectly. The surface deform modifier is pretty self-explanatory, you just add it to your object. The armature modifier takes a little bit more doing. To make it so that the vertex weights on the object are exactly the same as those on the breasts, you want to use a data transfer modifier. Make sure you set it first on the stack. Set it to vertex groups. For the mapping, I usually go for nearest face interpolated. Remember to generate the groups and click apply. And that should pretty much do it. So that's how you attach a solid object. What do you do about draperies? So here I've modeled a simple piece of cloth that I would like to attach to the breasts. As you can see at the moment, it is not attached. So the way we're going to attach the cloth partially is we're going to have a vertex group that's going to tell us the influence of the transform on the cloth. Now you could use the same method as we used previously for the pasties, but let me show you the second method. This method might be slightly better because instead of trying to match the transform of the breast, it tries to actually copy the location of the breast mesh. In some cases, you might not be able to match the transforms like we did here because the transform is too complicated or some other reason, who knows. In cases like that, you want to use this method. So the way we're going to do this is we're going to use geometry nodes. To start off with, create this setup that for each vertex of the cloth mesh samples the nearest position of the breast mesh. Next, we want to capture the indices that are nearest for each vertex of the cloth mesh. Basically, what we're going to do is that for each vertex of the cloth mesh, we're going to pick the nearest vertex of the breast mesh, and we're going to copy the transforms of that vertex. So the way you capture an attribute such as the indices that we want here on frame 1 to be used later is using the simulation node. So add a simulation zone and a capture attribute node. To the capture attribute node, pass the index that we got from the sample nearest node, and then pass that index to the simulation node. As you might already know, the input of the simulation node only accepts input for the first frame of the simulation. That means that whatever the capture indices are on frame 1 are going to remain the same for the rest of the simulation. Next, add another capture attribute node before the simulation zone, and pass in the location that we got from the sample index node. This is going to be the rest position for the breast. Don't forget to pass the index and the position from the input simulation node to the output simulation node. Next, add another sample index node after the simulation zone, set it to position, and pass in the index from the simulation output. Pass this position into the top input of a vector math node, and to the bottom, pass the position that we got from our simulation output, and then pass the result to a set position node. Now you'll see that the cloth perfectly follows the breast just as we had with method 1, but we only want part of the cloth mesh to follow the breast, so this is where the vertex group is going to come in. So I've made a pin group like so. To pass in this vertex group into our geometry nodes, use a named attribute node. and type in the name of the vertex group that you just created. Then after the subtract node, add another vector math node, set it to scale, and for the factor, add the pin group. Now only the pinned vertices are bound to the breast mesh, and the rest are free to follow the cloth simulation. Don't forget to add a collider for the breast using one of the two methods that I showed you. And yeah, you're pretty much done for this part. For our next challenge, we're going to try to make this breast being pushed against glass effect. If you just want a quick and dirty way to do this, it's really simple. Just add a geometry node and copy this setup that I have here. Basically, it's just one operation. We take the smooth maximum or the smooth minimum depending on the direction, and that squishes the breast in a given direction. It's a little bit more complicated if you want to squish in an arbitrary direction. For the sake of pacing, I will not be covering this, but leave a comment if you're curious. Okay, so I would feel bad if I just left it at this, so let's try to add another wrinkle to this effect. So we're going to try to add a little bit of a delay so that the breast kind of feels like it's dragging across the glass. So I'm not going to go through it step by step this time. I'm just going to explain what the setup does, and you can pause the video and copy the setup if you want. If you're a beginner when it comes to geometry nodes, you might want to skip this part. It's just going to confuse you. It's very technical. So the basic idea in this effect is that we want to capture the position of the breast when it first hits the glass, and then we want to interpolate that position with the projected position if there was no drag effect being applied. Whenever you want to capture data in time, generally speaking, you need a simulation zone, and this time is no exception. So let me try to explain what the hell is happening here. So the way we got this set up, there's two geometries here. So one is the projected geometry when there is no drag effect being applied, and the other is the geometry that is the final geometry basically, which is in the simulation zone. We want to transfer the position of the geometry that is dragging to the final geometry that is in the simulation zone under certain conditions. And that's really the crux of this setup, what this setup does. And how we do this is with the sample index node. Whenever you want to sample properties between different geometries, you can use the sample index node. In this case, we know that the indices match one-to-one between the geometries because they're the same geometry just with different transformations applied to them. So what this middle section here with the sample index nodes and the capture attributes nodes does is basically just that. It just transfers certain properties between the geometries. So from top to bottom, these are a boolean that says whether a vertex is being pressed against glass right now. The dragless position scaled by a knotted version of that boolean, I will explain what this is used for in a bit, and the dragless position. So at each iteration of the simulation loop, we are updating the position that we are dragging towards. This is why we need that boolean that I mentioned previously. If the boolean for a given vertex is 0, that means that it's not dragging yet, and we want to capture the drag position anew. If the boolean is 1, that means that we are dragging, and consequently, that means that we want to interpolate between the drag rest position and the projected position, i.e. the position if no drag was being applied. To finish the effect, we want to move the drag rest position towards the projected position a little bit each time we loop. This means that the breast final position will slowly edge toward the projected position. Sorry if that was a little bit hard to follow, it was really hard to explain as well. But yeah, if you take nothing else away from this, I would say the most educational part here is how to transfer attributes between different geometries. And you can do that using the sample index node. Although usually you would get the index from a sample nearest node. As homework, if you want to improve this effect further, you could add some volume preservation. So basically the way you would do this is that you would try to estimate the volume that is being lost due to the squish, and you would push the part of the breast that is not being squished along the normals. Let me know in the comments how it goes. Alright, I have one more effect for you guys in this video, and that is a wave effect. Now you could use the wave modifier here, but just for the sake of education, let's build our own using geometry nodes. So you could make this effect a lot more sophisticated if you wanted. I think this is more or less the most basic version of this effect, but I think it's good for an educational video such as this. So anyway, let me explain the effect. Looking at the nodes around the end, you'll see that we have a single set position node to the offset of which we're plugging in a scale node, which has the normals as input and a factor. So basically this factor is the amplitude of the wave, and the direction of the wave is given by the normal. So let's see how this amplitude is being calculated. Let's first look at the bottom row of math nodes in the left side of the node tree. This is effectively calculating the phase of the wave. As you'll notice, we're adding a distance and a multiple of the scene time. So that means that the wave travels in space as it gets further away from a set location and in time as time progresses. The epicenter of the wave is defined by a location given by an empty. This is what that distance node calculates, the distance to that empty. In the middle row, you'll notice we're doing some operations on this distance. First, we're taking a reciprocal, and then we're taking a power, and then we're multiplying it with the phase. The reciprocal is so that the amplitude decreases as the distance from the epicenter increases. The power is so that we can control the rate of the decrease. The top row is not really needed. I just thought it would be cool. What it does is, again, based on the distance, it pushes the mesh away from the epicenter. So there you have it. Feel free to modify this effect for whatever use you have for it. The image I had when I was making this effect was like there was a ghost sort of where the empty was, and it was sort of distorting space as it was floating around. But yeah, that's just my inspiration for this effect. Depending on what kind of wave you want, you should change the effect accordingly. And yeah, that's basically it for this video. I hope you learned something. I really tried to make this educational. I highly recommend giving this a go, like making little effects for your model. It's really fun, and it's really nice and a really nice way to learn more about geometry nodes. I'll do more of these videos in the future if there's a demand for it. Please leave any suggestions you have in the comments. And with that, I'll see you next time.